Alright, so today we're going to start on chapter 9, which is the first two sections, 9.1 and 9.2, are what's called scatter plots and lines of best fit. So, let's go ahead and look at what that means. We'll start with the key vocab word of a scatter plot. So a scatter plot is a graph that shows the relationship between two data sets. The two sets of data are graphed as ordered pairs in a coordinate plane. Okay, so scatter plot is a graph with a bunch of different points. Like I know leading up to now, most of the time when you graph something, it's in a straight line the whole time. Scatter plots are not like that. Okay, they will have points in various places, and it's not always in a straight line perfectly. So let me show you what I mean by that. Let's go ahead and jump into an example. So this is what a scatter plot looks like. As you can see, there are points all over the place. And then it's still on a regular graph like you would usually see. So this says, the scatter plot shows the average daily temperature and beach visitors on 11 different days. So with scatter plots, you have two different sets of data. Here, we have the average daily temperature, and then we have the number of visitors. So that is basically saying, like we're taking two different data sets and putting them together in one graph. So it says how many beach visitors, then there are three different questions. How many beach visitors were there when it was 89 degrees? So first we got to make sure we can read this scatter plot. So basically if it's asking you about the degrees, or if it's asking you about the beach visitors when it's 89 degrees, we need to go and find 89 degrees on the x-axis. So 89 degrees, here's 82, here's 92. So obviously right in between would be 90. So that means if we're looking for 89 degrees, in between 88 and 89, or 88 and 90 would be your 89. So here would be where 89 degrees would be, and then we just need to go up until we find the point, which is here, that matches up with that. So then when we find that point, we say, well, how many visitors does that match up with? And that matches up with 525. So part A, for how many beach visitors were there when it was 89 degrees, that would be 525 visitors. All right, part B. It says, what was the temperature when 300 people visited the beach? So this is backwards. So now they give us the visitors. So we go to the visitors. They give us that there were 300 visitors. So that's here. Then we just go over until we meet a point, which is there. And they want to know the degrees or the temperature. So we go down to the x-axis and see what the temperature was. Here it's meeting the line in between 84 and 88. So that would be 86 degrees. So 86 degrees was the temperature when 300 people visited the beach. What tends to happen as the number of visitors as the temperature increases? So we also need to be able to recognize trends with this. So as the temperature increases, so as the temperature is going up, what's happening to the visitors? So you can just pick out some points to try and understand this. So like when it's 84 degrees, there were 225 visitors. When it was, 92 degrees, there were 450 visitors. When it was 96 degrees, there was around 550 visitors. So what tends to happen to the number of visitors, the temperature goes up? So part C, the visitors increase, which makes sense. As you see the temperature increase, then you see the visitors increase. And you see that by the scatter plot, which it's going in this direction. And we'll talk about that a little more as we go on. But that is what tends to happen as the number of visitors, or as the temperature increases. The number of visitors also increase. Okay, so this is just another one kind of on your own, using the same scatter plot. Part A says, how many beach visitors were there when it was 84 degrees? So we're doing the same thing. We go to 84 degrees, find the point, and then we go over to the number of visitors, and that was 225 visitors. when it was 84 degrees. Okay, next it says, what was the temperature when 600 people visited the beach? So I go up to 600 people and go all the way over till I meet my point. And then at that point I go down, and that reaches this line, which is in between 92 and 96. So that means that is 94 degrees. So the first thing, which is not too difficult I don't think, is just making sure you can read the scatter plot, understand what the points mean, how they relate to both the x-axis and y-axis. So that is what that activity covers there. So moving on. There are three main types of relationships that you'll deal with in 8th grade. As you go on, you'll find a couple more, but for now, these are there's three main types of relationships when it comes to scatter plots. They are positive linear relationship, negative linear relationship, and no relationship. So it's either positive, negative, or no relationship as far as we're concerned right now with types of relationships. So let's look at what that looks like in picture form. So as you can see here, this kind of goes along with what we've talked about before when we talked about slope. The positive linear relationship goes upward. So all these points are not in a straight line by any means, like one straight line, but they all go in the same general direction, which is going up. So as you can see, as that x-axis increases, the y-axis also increases. So understanding that is important with positive linear relationships. And now, if you think about slope, this has a positive slope. It's going up. So that is a positive linear relationship. A negative linear relationship is just the opposite. It is going down. The general direction of it is going downward. So as this x increases, so as whatever the x-axis is, as it increases, the y is actually decreasing as that happens. Okay, so that's something to understand as well, is as that x increases, the y decreases. And then lastly is no relationship. If it's so scattered that there's no real general direction, it's not really going up, it's not really going down, it is just completely scattered out, that is considered no relationship. Okay, so that is the last one. So, what you to describe, this has to describe the relationship between the data. So here, this first one's pretty good, easy. It says, it shows this table or this graph, and we have a bunch of points on it. And as you can see, the main idea of it though, it is mainly going in that positive direction. It's mainly going up completely. So, what that's saying is, part A, first of all, we know it's positive linear relationship, so I just put PLR for that, because it's going up. But it says when it says describe, it wants us to actually describe the data with what is happening, okay, or with the labels they have. So that's going back to what I said. As the x increases, you have to tell what the y does. So here we have size in carats. So this is talking about like a diamond or something. So as the size in carats increase, so that's how I would start to describe it, as the size in carats increases, then I tell what happens to the y-axis. The price, then we talk about what happens to it. With a positive linear relationship, it also increases. So the price increases. So that's all your answer would be. And that's kind of the pattern you can go with each time. You always start with as the size in carats, or as the x, whatever the x is, increases. Because you're always talking about the x increasing. And then you describe what's happening to the y, whether it's increasing or decreasing after that. With positive, the y will be increasing. With negative, the y would be decreasing. Okay, let's look at part B. Part B will be a little tougher if you're just getting introduced to this, because at first look, you're like, well, that doesn't really, that's pretty spread out, so it's not going to have a relationship. It's going to be no relationship. But, again, this isn't what's called an outlier. It's away from everything. But the overall, taking that out of view or out of thought, the overall is still, I know it's more spread out than this one is, but it's still kind of going in that negative direction where it's going downward. Like, I know it's larger and wider, but it's still going in that downward direction. Like if I had more here and more up here, then you could make the case for no relationship. But here, this is still going in that negative direction overall, so this would actually be a negative linear relationship. Negative linear relationship. It's actually very difficult to have a actual no relationship. It has to be completely spread out. So if you have actual like open areas like this, it makes more for the case of it being a negative linear relationship. So with it being negative linear relationship, we have to describe it. So I say as the x, which it says kilometers run per week. So as kilometers run per week increases, because we're always talking about the x increasing, the weight, so weight is your y, so as you start running more per week, what happens to your weight? It decreases. So the weight decreases. So that is how you would describe that relationship. Okay, so that's the main idea with that, is you're looking to see how they're related, and then if they are related, you describe your x, as your x increases, what happens to your y. If it's an increasing or a positive relationship, your y also increases. If it's a negative relationship, your y will then decrease as that increases. So that is kind of the idea of describing your relationship. If it truly is a no relationship and like it's completely scattered out, there's no describing. You would just say it's no relationship and that's the end of the story because there's no pattern with the x and y. Alright, so then let's look at what's called the line of best fit. This says a line drawn on a scatter plot close to most of the data points, it can be used to estimate data on a graph. So line of best fit is basically saying you're drawing a linear line or a linear relationship, so a straight line that goes through most of the data points. And this next slide will give a better explanation of something when you draw it. It says when drawing a line of best fit, you want to try to make it go directly through the set of data points. If possible, you want as many points above the line as below the line. So when you draw a line of best fit with your scatter points, and I'll show you on the next slide, you're not wanting it to go like above them, below them. It's wanting to go directly through them, and then when you go directly through them, you want to try and make as many on top as on bottom. So let's look at an example of what that looks like. So say they give us, going back to the first example, or first graph scatter plot they gave us. So what we're not doing here is just like connecting the dots. That's not what we're doing. We want to draw a straight line that goes through the data points, leaving as many on top as on bottom. Here's what it's not going to look like. I've seen people do this before, like that. That is not what you're doing, because I understand, yeah, you have 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6. You have the same on both. But you want it to actually go through the points. You want it to go in the same direction as like the type of relationship it is. This is a positive linear relationship. So we need to make a positive line going through this data set. So here's what another one that it will not be. It will not be like this. Because here we only have 1 below the line, but 10 above. So that is not a good representation of the line of best fit. Neither would this. This would also not be a good line. Because again, we've got like 1 up here and then 10 down here. So you want to make it go directly through in the same direction while making sure you're going, like I said, in that same direction. That's the key part of that. Because the worst thing you can do is make lines going like just straight through it, but in the wrong direction. So here, my line of best fit would probably look something like that. Okay, so because now we have 1, 2, 3, 4, 5, 6 above, 1, 2, 3, 4, 5 below. That's pretty good as far as making sure it's going directly through the data and then having a balance on both sides. And I mean, that's not like the only line you could draw. Like you could draw something that looks like that, where now I have 1, 2, 3, 4, 5 below, 1, 2, 3, 4, 5, 6 above. It's just a matter of making sure you're paying attention to where that line is going through. So that would be a good line of best fit as well. A lot of the times, you won't even have to actually draw the line of best fit. They're going to just make you pick out which one's the line of best fit. But if you can draw it, you can obviously pick it out and make sure you know which one is the line of best fit. So understanding what that means and how that looks on a scatter plot is very important. So that pretty much covers 9.1, 9.2. Hopefully you understood all of that. Scatter plots, their relationships, and lines of best fit is the key ideas with that. So hopefully we have a better understanding of that now, and we understand it going forward. Thanks.